Okay, so part A is asking you to sketch the solution curve, and you have to go through 0, 1. So 0, 1 is right here, and we have to go through that. So let me just point this out to you so you see all the slopes here kind of going up, and then they sort of level off and then come back down. So you are going to want something that kind of goes like this and then comes back down. And let's take a look to the left of this point. See how these slopes go down. They're a little steep though. Notice those slopes are a little bit steeper maybe than these slopes. So I would make this kind of scoop down a little bit more, see how it levels off, and then it goes back up again. Okay? All right, so generally speaking, I would say kind of like this-ish. And then, like I said, this is a little bit steeper, so I'm going to come down a little bit lower maybe. And then that-ish. And there we go. All right, let's look at part B. Part B wants the equation of a line tangent to the curve. So, line tangent to the curve, you should be thinking y minus y1 equals m times x minus x1, and they gave you the point, so let's plug that in. So we've got y minus 1 equals m times technically x minus 0, but you could just write x if you want. All right, well, what do we need to find now? We need to find this slope. Okay, so remember, this is the equation for slope. So we're going to take that slope and we're going to evaluate it at the point that they gave us, which was 0, 1, right? Okay, so, oops, dy dx. If we evaluate that at 0, 1, let's see what we get. So we have 3 minus y, and y is 1, so I'm going to plug that in, times the cosine of x, and x is 0. All right, why don't you take a minute, work that out. So that should be 2 times 1, which is 2. So then I have y minus 1 equals 2. Actually, just times x. Now, if you wanted to, you could write that as 2x plus 1. Either one of these is absolutely fine. All right, and then the last thing they want you to do is use that equation that you just got and approximate f of 0.2. So I'm going to use this bottom one and just put in 0.2 here. Okay, so let me put my pen on. And that means f of 0.2 is going to be approximately 2 times 0.2, which is 0.4, plus 1. So then f of 0.2 is approximately 1.4. All right, so it says to find the particular solution. Remember what that means to do. So we're going to cross multiply and we're going to separate variables, and let's go from there. So when I cross multiply, I'm going to get dy equals 3 minus y times cosine x dx. Okay, well, all my x's are together. I'm just going to move that 3 minus y over. Divide that out. And there we go. So now our y's are on the left, our x's are on the right. What's the next step? Hopefully you're saying that you should integrate both sides. Okay, now let's just take a look over here. What are we going to have to do over here? Okay, we're going to have to do u substitution, right? I am just going to throw the u over here, if that's okay. So my u is going to be 3 minus y, which means my du is going to be negative dy. Okay, so let's just take a careful look here, because I have a negative dy, but here I have a positive dy. So that means, what am I going to need here, and what am I going to need on the outside? Okay, so on the outside and the inside, I'm going to have to multiply by a negative 1. All right, so then that's going to give me negative the integral of du over u, and over here I have the integral of cosine x dx. All right, well, on the left-hand side, the integral of du over u is ln, but it's going to be negated, and it's going to be ln of u, which we know is 3 minus y. So I'm going to plug that back in because we don't have bounds. So remember, when you don't have bounds, you plug the u back in. Equals, and the integral of cosine, which is the sine, plus c. Okay, and then from here, next step, let's plug in the value that they gave us, which was 0, 1, right? So 0, 1, and let's solve. So we have negative ln of 3 minus 1 equals the sine of 0 plus c. So this is going to be negative ln of 2 equals c. All right, so I just rewrote what I had on the previous slide there. So now I can write negative ln of 3 minus y equals sine of x minus ln of 2. So the first thing that I'd probably like to do to get y by itself here is to get rid of that negative, which is going to negate this, and it's going to turn that into a positive. So I'm going to have the ln of 3 minus y equals negative sine x, and that is going to become plus ln of 2. Okay, now think about how we get that y by itself, because right now that y has an ln attached to it, and that's the first thing that we want to get rid of. So remember, how do we get rid of an ln? Don't we e both sides? So we're going to e this, we're going to e this, and we're going to e this. And notice at the end here that that e and that ln will cancel out. But let's talk about, well, actually, let's do this. Let's leave that left-hand side, and that's going to leave us with 3 minus y, right? Okay, now let's look at the right-hand side here, because on the right-hand side here, we e'd. And remember, whenever we e or we ln, what does an addition sign mean? With regards to e and ln, what happens when we have addition? Doesn't that turn into multiplication? So this 2, remember the e and the ln cancel out, so this is just a 2 now. And we're not adding 2, we're actually going to be multiplying 2. So then the way I want to write this is we're going to have 2e to the negative sine x power. Okay, so that 2 comes in front. All right, now I'm trying to get the y by itself. Now, honestly, guys, I think the easiest thing to do would be to take this thing here on the right-hand side, scoot it over to the left, and negate it. And then take this negative y and scoot it over to the right. Okay, so then that's going to leave me with 3 minus 2e to the negative sine x. Okay, so I just changed the sign to negative, that's all, equals positive y. And there's your answer.